discuss how to compute for the deflection of beams using the double integration method and moment area method. In this problem, we are asked to determine the deflection at each span. Looking at the diagram, we have here a simply supported beam, the 6 meter span, and a 12 kilonewton concentrated load at the middle. The first step to get the deflection is to get the reactions of the supports. Solving for reactions, summation of forces along the horizontal is equal to 0, right side positive. Since nag-iisa lang yung horizontal forces natin and walang ibang kumukontra na force, that means yung value niya is 0. Next is summation of moment at A is equal to 0, clockwise positive. Yung 12 kilonewton na load natin multiplied by 3 meters, which is yung distance niya, distance between the load and yung sa A, minus reaction at B multiplied by 6 meters, which is yung distance niya din papuntang A, equals to 0. Negative kasi pa-counterclockwise. And pag kinompute, reaction at B is equal to 6 kilonewton upward. Since positive, that means tama yung shows na direction natin for reaction B. And summation of forces along the vertical is equal to 0, upward positive. Ilalagay natin yung nakuha nating value ng reaction B, which is 6 kilonewton minus 12 kilonewton na load plus reaction at B. Vertical is equal to 0. And makukuha natin na reaction ng A, vertical is equal to 6 kilonewton upward. So next step is ikakat na natin yung beam arbitrarily sa part na to. Magiging ganito yung diagram niya. Ikakopy lang natin yung mga forces dito sa left part, yung nakat na beam. Since hindi natin alam yung distance ng from A until dun sa nakat na part ng beam, i-integrate muna natin siya as x as well as yung distance ng load hanggang sa nakat ng part na beam. And indicate natin siya as x minus 3. After that, mag-moment na tayo dito sa part ng cutted na beam. Summation of moment is equal to 0, clockwise positive, 6 times x minus 12 x minus 3 minus m is equal to 0. Pag i-arrange natin siya, magiging m is equal to 6x minus 12x minus 3. After that, sisimulan na natin yung double integration method. Using yung formula, EIY prime is equal to m where EI is constant. So substitute lang natin yung nakuha nating value ng m. Yung makuha natin is EIY double prime is equal to 6x minus 12x minus 3. Pag in-integrate natin siya, EIY double prime maging EIY prime 6x over 2 maging 3x squared minus 12 prime maging EIY 3x squared over 3 maging x cubed minus 6 over 3 maging minus 2 x minus 3 squared x minus 3 cubed plus c1x plus c2 kasi nag-integrate tayo, magdadagdag ulit tayo ng constant. Kaya dalawa yung unknown natin na value. Gamit tayo ng boundaries which is kukunin natin sa support ng beam. First, hanapin natin kung saan nakalocate yung hinge support natin, which is located at x is equal to 0 and y is equal to 0. Pag sinubstitute natin siya dito sa equation na to, wherein x is equal to 0 and y is equal to 0, ang kukuha natin ng value ng c2 is equal to 0. And next is yung second na support, which is yung roller natin. Roller support located at B. And located siya sa 6 and y is equal to 0. Pag sinubstitute natin siya dito, wherein c2 is equal to 0, ang kuha natin is EI y is 0 is equal to 6 cubed minus 2, 6 minus 3 raised to 3 plus c1, 6 plus 0. Ang kuha natin value ng c1 is equal to negative 27 kilonewton meter square. Pag nilagay natin itong value ng c1 dun sa equation, kukuha na natin yung deflection equation, which is EIY is equal to x cubed minus 2x minus 3 raised to 3 minus 27x. Since yung required is the deflection at midspan, isa-substitute ulit natin yung x is equal to 3, which is yung midspan, dun sa deflection equation. EIY is equal to 3 raised to 3 minus 2, 3 minus 3 raised to 3 minus 27 times 3. Since 3 minus 3 is equal to 0, makakancel ito, magiging value ng EIY is equal to negative 54 kilonewton meter cube. Negative value kasi pababa yung magiging deflection. And pag in-arrange natin, EIY is equal to negative EI deflection, magiging EI deflection at mid-span is equal to 54 kilonewton meter cube, or deflection at mid-span is equal to 54 over EI kilonewton meter cube.
Next method is the moment area method. So we have a simply supported beam with a 6 meter length and 12 kilonewton load at midspan. So we are asked to determine the deflection by using moment area method. So first we will solve the reaction. So summation moment at A is equal to 0. So RB times 6 meter minus 12 kilonewton times 3 meter is equal to 0. So RB is equal to 6 kilonewton. Then summation vertical is equal to 0 along the positive along the vertical axis. So RA plus RB minus 12 kilonewton is equal to 0. So RA is 6 kilonewton. So we can draw the diagram. So show diagram first. So positive 6 kilonewton minus 12 kilonewton is equal to 6, negative 6 kilonewton. Then negative 6 kilonewton plus 6 is equal to 0. Then moment diagram is yung area lang nung shear diagram. So, 6 times 3 is positive 18. Then, negative 6 times 3 is negative 18. So, positive 18 minus negative 8 minus 18 is equal to 0. Then, yung elastic curve. So, as you can see, the elastic curve is downward. So, this beam is deflecting downward, and this elastic curve represent the shape, and the distance to the beam to the elastic curve is the deflection at that point. So let's say it's delta B. Now we're gonna draw a tangent line to find the angle rotation at point A. Let's call it theta A. So this distance here is delta BA is simply the distance from the elastic curve to the tangent line down from point A. And this is actually called the theorem 2. So the summary, delta BA is equal to integration m over EI, here, m over EI times bar x, which is the distance from point B to the centroid of the m over EI diagram, and dx. So to solve, we get the area of the moment diagram, So 1/2 times 18 over EI times the distance is 3 meter. Then yung bar x niya, yung centroid, is 1 meter. Then times 2, because it's symmetrical triangle, we come up with a answer of the deflection to 54 kilonewton meter cube.